Wow, that was refreshing. Okay, but now we're going to get right back to it. Right now, our podcast is we're going to be looking at Newton's second and third law. So let's see what we can find out about that. So we're going to start off with Newton's second law. Here's the formula that we've dealt with before. We want to see what the relationship is between force and mass and acceleration. In particular, we can change the force, we can change the mass. Let's see how that affects acceleration. So in order to do that, I'm going to rewrite this formula so it says acceleration equals force divided by mass. It's the same formula, don't worry about it. But let's look at what happens with acceleration and force first. If I increase my force here, because they're both in the numerators, the acceleration is going to increase as well. Double the force, you double the acceleration also. This is what we call a direct relationship. If I was to plot this out with the acceleration on the x-axis, the graph of force as it changes would look something like this. Basically, as the acceleration is increasing in this direction, the force is increasing in this direction. We call that a direct relationship. You need to write that down. That's one of our key terms. And you also need to make sure you copy down that graph because we'll ask you to copy that graph down on a future quiz or test. Okay, so now we want to see what the relationship is between mass and acceleration. So again, we're going to start off with our rearranged formula, but now if I increase the mass, the acceleration is actually going to go down. You can see that here. If I increase this mass, remember it's in the bottom of a fraction. If I increase the bottom number of a fraction, it can go from 1/10 to 100th to 1,000th to 1,000,000th. That entire answer, that entire fraction, this acceleration gets smaller and smaller. So we have a separate name for that. But let's take a look at the graph of this first. If I have a graph of mass and acceleration, what we're going to see is it's going to look like this as it changes. We call this an inverse relationship. If our mass starts off really big, it has a very small acceleration. Think about it. If you have a huge object like a car and you try to push on it, it's not going to accelerate very much. But as that mass gets smaller and smaller and smaller, the acceleration that I'm able to apply to it is getting bigger and bigger and bigger. So if I supply the same force on, say, a very small object like a piece of paper, I can accelerate it a lot bigger. So again, we call that an inverse relationship. Okay, now we're going to actually solve using Newton's second law, F equals ma. But in order to do that, we need to go through all the steps that are required to get full credit on tests and homework. And we call this method the guess method. The reason we call it is because they each stand for something. The givens, the unknowns, the equation, substitution, and the solution. We're going to go through each of these steps using the little formula that you see right below us. On your page, and we're going to fill these in one step at a time. The first thing we're going to start off with is read the problem and identify my givens. And these are the only two things I know. The force being applied is 50 newtons. Look at those units. They tell you exactly what measurement is being made. Newtons is always a force. Kilograms is always a mass. So write it out exactly like this and you'll be great. Our next step is to identify our unknowns, and our unknown in this case is our acceleration. This is our question word. What are we being asked to solve for? A, for acceleration. I'm going to leave it as a blank just so I have an indicator that this is what I'm looking for. Next, we want to write the equation down. Not numbers in the equation, but the equation by itself, the naked equation. The reason is it helps you plug in the numbers on the next step, which is substitution. So we're going to take the numbers that we had over here, and we're going to bring them right underneath that formula. Always do it underneath because it's so much easier to keep track of all these. We know what the force is. It's going to be 50 newtons. We know the mass is 10 kilograms. Acceleration is unknown. We're going to bring down that variable a. Don't put an x or anything else. Leave the variable the same. Now, after that, we've got to do a little algebra. Now, to solve for acceleration here in this case, we've got to divide both sides by 10. So there's our next step, a little bit of our solution. And our final solution is we know that these two 10s are going to cancel out, which is going to leave us with acceleration equals 5. Now the final answer is meters per second squared. Acceleration is always meters per second squared. And so we want to leave that as our final answer. And it looks like I left off the 2 there, so I've messed up already. So even I do this when I go really, really fast. Okay? These are all the steps you have to include for all of your work. One of our final questions is going to deal with Newton's third law. Newton's third law says for every action there is an equal but opposite reaction. For every force, there's an opposite and equal force. So in this case, we've got a heavy truck and a little bug. They are going to collide. They're in opposite directions, and when they hit each other, there's going to be a little bit of a collision here. Not much of a collision. A bug isn't very heavy. And the question is, which object is hitting with a bigger force, the car or the bug? And Newton's third law is very explicit about it. The answer is it's equal forces in opposite directions. It doesn't matter how big the truck is, doesn't matter how small the bug is. When they hit each other, they're hitting with the exact same amount of force. The truck hits the bug is really light, so it doesn't actually have much of a chance to hit it very hard. The bug is so small it moves out of the way. The bug is so small that when it hits the truck, it doesn't have enough speed or force to actually cause the truck to move out of the way. So even though there's a big change in the motion of the bug after they collide, the bug's going to be a little wet spot on the windshield. The force that the truck felt is the same force that the bug felt. Okay, so that's our quick lesson on Newton's second and third law. We'll see you guys later in class.